Hi guys, so in this video we're going to be talking about how to tell that a limit in 3D does not exist. So remember that for our 2D limits, it wouldn't exist if it approaches something different from both sides. So say from this side it approached this value, but from this side it approached something completely different. So the limit at this point definitely wouldn't exist. Well, in 3D it's a little bit more complicated because it approaches this point from a lot of different directions, not just left and right. It approaches it through different lines and different functions. So this is going to be a harder drawing, but a limit that wouldn't exist. Maybe it would look like this, something like that. So at both of these points, it approaches something different. Anyways, the way that we test for this, say we have a function we're going to approach the point 0, 0. So both x and y are going to approach 0 in this function. So what we really have to do to prove that this limit does not exist is to prove that it approaches a different value from at least two different directions. So let's see. If we went along the x-axis, say here, we went along the x-axis, we're approaching 0 along the x-axis. So really, in that case, along the x-axis, it's going to approach, xy is going to approach x, 0. We're approaching 0 along the x-axis, so y is going to approach 0, x is just going to keep changing. So it's going to be x squared minus 0 squared over x squared plus 0 squared. So it's just x squared over x squared equals 1. So the limit along the x-axis, as we approach 0, 0 along the x-axis, is going to be 1. What about along the y-axis? So it's just going to be the exact opposite. The y value is going to vary, it's going to get closer and closer, the x value is going to become 0. So xy is going to approach, well, it's going to be 0y, which means we just plug in 0 ever there's an x, negative y squared over y squared. And that's the same as saying negative 1. So over here, look, we have two different values. So we have something like this going on, where from one side it's approaching one value, from the other side, well, using two different ways, we're getting different values. So the limit clearly doesn't exist in this case. Let's try another one, because we can approach along the x-axis, we can approach along the y-axis, but there are so many different ways. And sometimes these will both be equal, but you'll have to find another one that isn't equal. Okay, so let's try limit as xy approaches 0, 0 of xy over x squared plus y squared. Okay, so let's approach 0, 0 along the x-axis first. Along x-axis. So same as over here, xy is going to, xy is going to approach x, 0. which in this case is going to, we just plug 0 into all of our y's. 0 over x squared plus 0. So, well, 0 over x squared equals 0, so it approaches 0. What about along the y-axis? Just plug in 0 for all of the y's, or sorry, for all of the x's this time. So it's going to be 0 over y squared this time, which still equals 0. So that's great. So far, we do have two that are equal, so we haven't proven that it's discontinuous. But just because we've gotten these two, remember, that doesn't mean that it is continuous at all. We have so many other directions that we have to try. So how about we try x equals y? So this is just going to be a line. So for, okay, say we did this in 2D, we're just approaching from various lines. We approach from x-axis, y-axis. Now x equals y is just a line that looks like this. We're trying to approach 0 from this one now. So x equals y. Let's just turn all of the y's into x's this time. So it's going to be x squared, x times x is x squared, over x squared plus, substitute an x in here, x squared, 2x squared. So this will actually equal, the x squares cancel out, 1 over 2. Clearly this is different than 0, so we only need 1 to be different for it to be discontinuous, and therefore it is discontinuous.